Hello everyone, it's Tuesday, November 10th, and this is our agenda. So if you're watching this video, you are doing a review of my video lesson. I did a live lesson in class, and either you missed it or you are reviewing what we talked about. On November 10th, Tuesday, we're beginning our investigation into our star, the Sun, called Sol. I'm giving a live presentation to all the students. And this agenda slide says if you missed it to click here. So that's the video you're watching. If you were not present for our live lesson, you should click this peardeck lesson link and it'll take you to the student directed peardeck lesson for our introduction to the Sun. And in that lesson, you'll find this link as well, the Quizlet for our key terms. You can find this link here to practice our key terms. We will have a quiz on those when we're all done with learning about the Sun. In our peardeck lesson, we have new terms that we're using. Roomers are the students that are presently in the class, and they are interacting with the Googlers, who are the students that are online on their computers. The roomers are going to use the classroom tools I provide, and the Googlers are going to respond to the questions right on their peardeck. Again, if you missed any part of that lesson live today, interacting with your class, then you should click the peardeck link that's found in your agenda. The first thing that we did was to create a text box and to write down two things that we already know about the Sun. It could be any two things that you already know about the Sun. So you put a text box here, and you write one thing about the Sun here that you know, and one thing about the Sun here that you know. We're going to be talking about the Sun by discussing the Sun's interior, the core, the radiation zone, and convection zones. There's 3 layers to the Sun's interior, 3 regions. The core is the very center of the Sun. It's where energy is made. Once the energy is made through a process called nuclear fusion, the energy moves outward through this very dense zone. This region is called the radiation zone. It's very dense or tightly packed with gases. It's so tightly packed or dense that it takes the energy over 100,000 years to move from the core through the radiation zone. Once it reaches the top of the radiation zone, it enters this region called the convection zone. Radiate means to move outward. Convection is another process where hotter materials are less dense, so they rise up. They cool off at the top of the convection zone and they become more dense. When they're more dense, they're heavier and they fall back down. And it creates these circulation movements, this bubbling effect, almost like water that's boiling. You can see how the water moves because the water at the bottom of a pot is hotter than the top. And that's what's happening here in the Sun's convection zone. It takes the energy from the radiation zone to the top and it releases it, and some of it falls back down. So it creates a convection current. I want to talk a little more about nuclear fusion that's happening in the core. Stars are the only objects that can create energy through nuclear fusion so far. What nuclear fusion does is it takes 2 hydrogen atoms and it smashes them together so hard with such force that it fuses them or makes them stick. They join. Now, we don't have the ability to join hydrogen atoms here on Earth. We do not have the force, we do not have the heat to make it happen. And therefore, stars are the only objects that can. We're trying to make energy through nuclear fusion, but we have not succeeded yet. Now, when the Sun uses energy to force these 2 hydrogen atoms together, it creates helium. But helium has less matter than hydrogen, and therefore there's extra left over, and that's energy. So every time the Sun uses energy, it creates energy. And that's different than anything else that can make energy or use energy. When we use energy, it's gone. When you fill up your car with gas and you drive your car, the gas is gone. when you eat food and you burn calories, you use all your energy, that energy is gone. You have to eat more food to get more energy. And that's not what is happening with stars. Stars use energy. They make energy every time they use energy. So they last a really long time, and they're an endless source of energy, and they've created life here on Earth. Oops. This is a video that explains a little more about nuclear fusion. I'm going to take a couple minutes and allow you to watch this video. Come back to this lesson when you're done. So far we've talked about the three interior layers of the sun. We have the core, the very center, where nuclear fusion creates energy by taking two hydrogen atoms, joining them or fusing them to create helium plus energy. That energy moves through this very dense layer called the radiation zone. It's so dense that it takes 100,000 years for energy to move through it. So that means the energy that's created right now, right this second, in the sun's core, will not move to the top of the radiation zone until 100,000 years from now. Once it reaches the top, it enters the next region called the convection zone. Convection causes heat to rise, cool, and sink, bringing energy to the surface from the core. So here the energy rises up because it's less dense, reaches the top where it cools off, and then it gets heavier and it sinks back down. It creates these little convection currents, each time grabbing more energy from the radiation zone and releasing it. And that energy travels through space to the Earth. It's similar to how a lava lamp works. So with a lava lamp, there's a heat source at the bottom. It's a light bulb. And it heats up this waxy material. It could be any color. The one they're showing here is green. The hotter material is less dense. The molecules look like they are down here, more spread out. It's lighter, rises to the top. Now at the top of a lava lamp, there's no heat source, and therefore the molecules get closer together. They get more dense. They look like this, closer together. That makes them heavier, and they sink back down. And the process continues over and over again, rising and falling, and that is called a convection current. Here's part of our peardeck lesson. Here is what I think. How does the lava lamp model what is happening in the sun's convection zone? And you're going to write your response in the text box on your student paced peardeck. If you were in class, we did this together. On your student paced peardeck, you will read the questions and then drag and drop your icon to respond. The region of the sun where energy is created through the process of nuclear fusion. Drag the icon to your choice. Is it the core, radiation zone, or convection zone? The next question, pulse check, the region of the sun's interior where the gases are so thick or dense that it takes over 100,000 years for energy to travel through. Drag the icon to your choice. Is it the core, the radiation zone, or the convection zone? And the last question on the pulse check, the region of the sun where less dense hot gases rise up, cool off, and sink back down towards the core. Is it the core, the radiation zone, or the convection zone? And when you reach the end of your peardeck student paced activity, you'll find that there is a website, Quizlet, for you to review the sun's anatomy flashcards. So you're going to open the Quizlet, click on the flashcards to flip them, and then you can choose other ways to learn the words. These are the flashcards. Sun's core. When you click on the flashcard, it flips it over for the definition, the center of the sun where the process of nuclear fusion takes place. To go to the next card, click the arrow, photosphere. And you can learn all of the different terms that we're going to be studying for the sun's anatomy, the layers that make the sun. You can study the set looking like this in a list with the definitions and pictures. You can also choose to learn a learning game where you'll be able to match the words. You can choose to write them out. That's hard because if you spell them wrong, Quizlet tells you they're wrong. You could play a matching game. You can also play a gravity game where you have to drag and drop things before they hit the ground, or you could play a live version game, kind of like a quizzes challenge game or a Kahoot challenge game. So you could play around with your Quizlet and learn the words at the same time. If you are completing your student version of your Pear Deck for today, then make sure that you turn that in to me so that I can